convolution sum with a discrete signal. Already we have seen convolution formula with the time domain technique. Okay, there is a formula, and also we have again the same formula we can calculate either mathematically or graphically in case of time domain signal. Here also there are some procedure with help of that we can calculate the convolution operation for a discrete signal. So we know that y of n in general is equal to x of n convolution with h of n, where x of n is a signal, okay, is like an input signal. H of n is a system nature, that is also a signal, okay, that can also be represented in terms of some mathematical function, okay. It need not to be a signal, it's like some mathematical function. Say for example, x of n could be u of n. Okay, u of n means what? It's a continuous sample value with one. Okay, or it could be something with other values. Okay, continuously it will be going, or it may be some defined numbers. It may be like this 1.5, 2, 3, like a defined nature. Like there are only 4 samples. Okay, it need not to go up to infinite. Okay, only the x of n is present only for 4 values, 4 time index, and also they will mention where exactly n is equal to 0 is starting. Okay, so the arrow mark indicates that that is equal to n is equal to 0, or sometimes they may also give like this. Okay, the same samples they may also indicate like this. Okay, with the arrow mark at 0.5, that means what? This is n is equal to 0. Actually, the signal is starting at n is equal to -1. Okay, so clearly the arrow mark indicates that n is equal to 0. Okay, reference time. Okay, again, the signal may be defined in terms of certain samples, or it may be defined in terms of mathematical operations. Again, from the mathematical operation, we can also get the sample values. Okay, we know the sample values for the basic functions. Only the basic function they will give in terms of the mathematical representation. Okay, or otherwise directly they will mention the sample values. So now, what is the convolution formula for a discrete signal? Okay, the x of n, we know that x of n convolution with h of n formula is summation k minus infinity to plus infinite x of k h of n minus k. Again, we know that k is something like tau. Okay, tau is the variable that we'll be using in time domain. K is also a variable that we'll be using here in discrete domain. It's generally a delay operator. Delay operator. It is a delay operator. Okay. You know that tau means always it indicates the delay. Again, in the discrete domain, K is like a delay operator. That means either delay means either we can delay the signal or we can advance the signal. If K value is positive, we can delay the signal. If K is negative, okay, once if K is negative, here we will be getting plus. Again, we can advance the signal. That means we are going towards left side. If K is positive, we are going towards right side. Okay, so again, there are again with the help of this mathematical equation, we can find out what is y of n finally. Okay, but actually that is a little bit difficult because we have to do so many computation. Okay, suppose even if x of n is given like this and another h of n will be given, again we need many computations to finally calculate y of n. And also one more procedure is there. With the help of tabular method, also we can calculate this y of n. First, we'll go with this formula, okay, for a given problem. So the problem is like this. And before going to that, we have to remember one formula. Whenever the convolution operation is there, it has to satisfy the area formula. Again, area, continuous time signal means area. Here it is summation. Okay, that means the summation value of the samples of y is equal to the summation values of samples x multiplied the summation values of the samples at h. Okay, that means what? Summation x multiplied with the summation h should provide summation y. Okay, this has to be satisfied always. The first problem, using convolution formula find find y of n. They clearly mentioned using formula only we have to find y of n. So again h of n is given 1 comma 4 comma 3 comma 2, then h of n is equal to 1 3 2 1. Now again reference index is this one. Here they are not given anything. Even if they are not giving anything, again what is the assumption? The first one will take it as n is equal to 0. If they are not given anything, the first one is n is equal to 0. Okay, so now this is n is equal to 0, this is n is equal to 0. But again we are having here actually the x of n is going from where to where? It is going from -1 to plus 2. That means n varies from -1 to up to plus 2. That means n is equal to 0. This is n is equal to 1. At n is equal to 1, value is 3. At n is equal to 2, value is 2. That means the time index, okay, x of n is actually going from with the n -1 to with the n is equal to plus 2. Here h of n is going from 0 to 3. Okay, 0 to 3. That means what will be the nature of y of n? What will be the time index of y of n? We know that we have to add the lower limits. If you add the lower limits, we will be getting lower limits. Again, to get the upper limits, we have to add the upper limits. That is 2 plus 3. That means y of n will be going from -1 to 5. Okay, again, one thing we have to note down here. Okay, how many samples are there here actually? Here there are 4 samples. Here again there are 4 samples. But how many samples are there here? 5 plus 2, again 7 samples. Okay, so again there are some relation between the number of samples at x of n, number of samples at h of n, then number of samples at y of n. Okay, that is simply the length of y of n, okay, ly is equal to the length in x, the length in h minus 1. Okay, so how many samples will be there in the output, that we can easily find out with the help of this formula, okay, for this convolution. Okay, again this convolution also we'll call it as a linear convolution. There are another convolution, that is circular convolution. Their formula is little bit different, but in general the general convolution is called linear convolution. Okay, linear convolution. But whatever may be the convolution nature, either it is linear or circular, always this formula has to be satisfied, that summation formula has to be satisfied. But the length formula, the length of the sample will be different. Okay, again for a linear case, the length, okay, the number of samples, length means what? Number of samples at y is equal to number of samples at x, number of samples at the h, that is the second signal, minus 1. Okay, now we'll concentrate on the formula, that is y of n is equal to summation k minus infinity to plus infinite x of k h of n minus k. Even for a reference, we'll write here x of n is going from 0 to where? 0 to x of n time index is going from -1 to plus 2. H of n is going from 0 to 3. Okay, 0 to 3. Okay, now again, if you see here, just now we have identified the nature of y. Y goes from, definitely there are how many samples? 7 samples. And also limit also we have identified. The lower limit is the lower limit is -1, upper limit is 5. That means y of n goes from -1 to 5. Okay, so we have just identified this goes from n goes from -1 to 5. Okay, that means I know what I have to calculate. Okay, first of all I have to put n is equal to -1, then 0 1 2 3 4 5. That's okay. Again n, somehow we are fixing n because n can go from -1 to 5 at a time. We can calculate one at a time. We can concentrate on y of -1, then y of 0, similarly up to y of 5. Okay, then what about the nature of k? How far we have to vary the k? That is the question mark here. Okay, so how to identify that? Okay, again there are some simple ways to fix on this. Okay, just if you substitute, say for example, suppose if you are substituting n is equal to -1, then you will go from minus infinity to plus infinite, x of k, h of -1 minus k. Then what is the value of k? How far the k has to be varied? It is very simple. Just you observe the nature of this. How far x of n is going? Okay, because simply x of n will be writing as x of k, just variable is changing. That means again the k has to be varied from only from -1 to +2 only. The k has to be varied from -1 to +2. Even if you go beyond that, definitely you will be getting 0. Just now we'll try to understand that. Suppose if your k is going from -1 to +2, okay, then you are having this one. Suppose let us choose k is 3, for example. Suppose if I'm choosing k is equal to 3, what will happen? If k is 3, just if substitute here, first of all, you will be getting x of 3. Okay, when you choose k is equal to 3, definitely you are getting x of 3. I'm not worried about what it will come here. I may get a sample value, non-zero sample value, or I may not get. But what is the nature of x of 3? Okay, if you observe here, again the x of n is defined only up to 2 only up to 2, n is equal to 2. There is no x of 3. Okay, that means what? Irrespective of the value of these samples, definitely this sample is 0. Okay, so whatever may be the value here, definitely I will be getting 0. That's why my k value will be always in between -1 to +2. So it's very simple. K generally varies from what is the variation of x of n, because x of n we are mapping as x of k. So it's directly we can put the k variation from -1 to +2. So now we are having y of -1. That means summation k goes from -1 to 2, x of k, h of -1 minus k. Just we'll rewrite that. Y of -1 is equal to k goes from -1 to 2, x of k, h of -1 minus k. Just substitute the value of k. Suppose if k is equal to -1, x of -1, h of 0, h of 0 plus x of again k value as 0, h of -1, then x of 1, h of -2 plus x of 2, h of -3. Again, just observe the original signal. In the original signal, what is x of -1? Okay, this is x of -1 means at n is equal to -1, the value is 1. Okay, so 1. What is h of 0? Value is again 1. So multiplied with 1 again, plus what is x of 0? Okay, x of 0 value is 4. What is value of h of -1? Okay, so h of n is not defined for n is equal to -1. That means its value is 0. So put 0 here. Similarly, if you write all these things, definitely you will be getting 0. So finally, the value is 1. So y of -1 value is 1. Again, similarly, you can calculate other values. What is the value of y of 0? In summation, k goes from -1 to 2, x of k, h of n minus k, but in this case, what is the value of n? That is 0. Okay, so h of minus k. Okay. Then we'll be getting x of -1, h of 1, x of 0, h of 0, x of +1, h of -1, x of +2, h of -2. In this case, you will be getting 1 multiplied with 3 plus 4 multiplied with 1. Again, remaining things 0, 0. Finally, you will be getting 7 as the answer. Okay, so if you proceed in this manner, okay, you will be getting the rest of the values. Just I'm going to write the rest of the values directly. Okay, so y of 2 you will be getting as 20, y of 3 as 16, y of 4 as 7, y of 5 as 2. So finally, we'll write all y's sample values, output sample values. Finally, y of n is from 1, 7, 17, 20, 16, 7, 2. Okay, this is final y of n, and also we know that it will go from -1 to +5. Okay, 1, 2, 3, 4, 5. Yes. Okay. So again, what is our original x of n? Okay, uh, x of n value was 1, 4, 3, 2. Okay, what is the value of h of n? Simply 1, 3, 2, 1. Just now, finally, we have calculated the sample values of output sample values. Just we have to cross verify. Just we'll cross verify whether it is true or not. Okay. So what is the summation value of y? Okay, the summation value of y, you just add it. Again, similarly, what is the summation value of x? Okay, 1 plus 4 plus 3 plus 2. Okay, that is 10. What is the summation value of y? 7. If you multiply, you will be getting 70. Okay, then again, definitely the summation value of y will be 70. Okay, if you just verify it, if you add all this term, definitely you have to get 70. Okay, so it's just a simple cross verification whether to verify whether our answer is correct or not. Okay, so then what is the other method? Okay, other method, that method is called tabular method. Other method. Okay, so what is x of n? Now the same problem we are going to solve in the different with a different method. H of n equal to 1, 3, 2, 1. Okay, just again arrow mark here. Okay, just don't worry about the arrow mark. Okay, arrow mark will actually fix the time index. Okay, from where to where it is going. You know, we are worried about only the sample values. Finally, we can put the arrow mark. Just try a table. Again, how many rows and how many columns needed, it actually depends on how many samples are given both in xn and hn. Okay, suppose for example, I can take all xn here 1, 4, 3, 2. That means if you are taking xn like this, that many number of columns you need. If there are more number, again I have to put more columns. Okay, then similarly this we can put it in the row, that is 1, 3, 2, 1. Okay, now you just multiply this 1 with 1, 1 with 4, 1 with 3, 1 with 2. Again you multiply 3 with all this number, 3, 12, 9, 6, 2, 8, 6, 4, 1, 4, 3, 2. Now what do you do? Just you put line like this. Okay, so what is the number present in this cell? That is 1. Again in this cell 3 plus 4, that is 7. In this cell 12 plus 3 plus 2, 17. In this cell 8 plus 9, 17. 18 plus 2, 20. In 16, 7, 2. Okay, so now in this process, we have identified what is y of n. And also we know that this is n is equal to -1, n is equal to 0. Definitely this will start at n is equal to -1. Definitely the arrow mark will be here. Okay, just compare with our result. Okay, 1, 7, 17, 20, 16, 7, and 2. Okay, the same result we are getting here. Okay, so this is one of the simplest method by which we can easily find out what is y of n. Okay, so we will stop with this. Thank you.